What's up, math fans? I hope you tuned in for the content proving triangles are congruent and not just because it's Sweater Fridays. Or also to see if I shaved the beard yet. Alright, so I have two triangles right here. Looks like a bow tie. But I want to be able to prove that they are congruent to each other. And this time I'm going to use side angle side. So just to review, there are different ways to prove shapes are congruent. And if you're talking about two different shapes being congruent, if they're congruent, all the parts of one have to be congruent to all the parts of the other. That's for any shape. Specifically triangles, you need to have in order for triangles to be congruent, all three angles of one triangle have to be congruent to all three angles of the other triangle. And all three sides of one triangle, 1, 2, 3 sides, have to be congruent to all three sides, corresponding sides of the other triangle. And then we started talking about shortcuts. Do I really need to show 1, 2, 3 angles and 1, 2, 3 sides, or could I just show part of it and still figure out that the whole thing is congruent just by showing parts? So I did a video showing the first couple of shortcuts, and here's another one. I don't need all 6 things. I can prove it with a minimum of 3 things as long as they're in the right order. Side, then angle, then side. So hopefully this is enough information to do that. So let's say this is the given information here. You're given this one statement, and you need to be able to use that to prove that AMC, triangle AMC, which is this one on the left, congruent to this one on the right, DMB. So in order to prove something, yes, you can explain it and give kind of informal explanation, or you can do a formal proof where you say something and then you tell me why you said it. What is your reason for saying it? Your statement and your reason. The first thing you should say is generally the first thing you see. And if you look in this diagram, you don't see much. There's no real, I don't know anything about the angles, I don't know anything about the sides, I don't see anything. But this is a very good clue. Read it, think about what it means. Hopefully you learned this word a long time ago. Think about what that means. Is it a good clue or not? Is it telling you something or not? Well, let me see. It's telling me M is the midpoint of AB and of CD. So here's AB. AB goes like this. It's a diagonal line going from A to B. And M is the midpoint. What does the midpoint do? Cuts things in half. So that means this half from A to M is congruent to this half from M to B. That's good to know, and I put the dashes to show that from here to here is the same as from here to here. Even though I don't know the value, it doesn't matter. I know they're the same as each other, and they're corresponding. Keep that in mind, that's helpful. And it's also the midpoint, M is also the midpoint of CD. C to D is here, M is in the middle, which cuts it into 2 congruent halves. There you go. This is the same as this, even though I don't know values. Now I can start to talk. Now I got stuff in the diagram. First thing I want to say is what you told me. I'm going to repeat it. I know that M is the midpoint. Midpoint, as short for point, is PT, of AB. You could say NCD at the same time, or you could do it 2 separate ones. I'm going to say it at the same time. Okay, and why would you say that? Because it's right there. It's given. Now, that's all the givens. I was hoping there'd be more. That's all the givens. I'm already done. But look at the diagram. I know that AM is congruent to BM. And why am I allowed to say that? Because it's given? Yes and no. The dashes weren't there. It wasn't given. And nobody ever told you that. You concluded it because you know what a midpoint does. So, definition of midpoint. Hopefully somewhere in your career you learned the definition of a midpoint, and if you didn't, I'll tell it to you now. A midpoint bisects or cuts a line segment into 2 congruent halves. So you can conclude that this half is congruent to this half. That's the definition of a midpoint. What else can I say? Looks like more information in the diagram. CM congruent to DM. Why was I allowed to say that? It wasn't given. It wasn't there yet. You put it there. Why did you put it there? Because, again, definition of midpoint. All right. This one is the one that you don't see, but it's so common. It's very, very natural. when two lines intersect, they cross each other. And a lot goes on here. I've done this a lot. I'm not trying to say that I'm from the Bronx, but I am. This and this cross each other and they form vertical angles. Whenever I see two lines crossing, I should be thinking vertical angles. Whether it helps or not, I'm thinking about it. What do I know about vertical angles? They are congruent to each other. So this angle here is congruent to this angle here. AMC, let me write that, is congruent to angle DMB. And why are you allowed to say that? Because vertical angles are congruent to each other. That's the definition of vertical angles. Now look at the diagram. Finally, if you look at this, if this was the question and there were no words, you could say, oh yeah, those are the same, because this is corresponding to this is corresponding to this is corresponding to this. Side angle side is congruent to side angle side. It goes in a row. First the side, then the angle, then the side. Don't jump around and go, oh, I think it's side, side, angle. It's not. You don't jump and skip all this information in the middle. You have to go in order. So, that's it, I'm done. Conclusion is with the three dots. Triangle AMC is congruent to triangle DMB. Why? Side, angle, side, postulate of congruence. So now I know that these are exactly the same. If I folded it over and twisted it, they would lie on top of each other, and they are exactly the same or congruent. And now I know, okay, oh, well, I guess AC is also congruent to DB, and you can make all kinds of other conclusions. All right, but you can't assume. Don't say, oh, because it looks like it. That, you think I'm going to sit here and do 5-step formal proof, and then somebody else is going to accept it because it looks like it? No, you got to get the work done. Be patient, rewind, check it again if you're not sure. Like, share, subscribe. Thanks a lot for watching. See ya.